All right, guys, before we do anything in calculus, we first have to understand limits and graphs. So to understand what a limit is, think of this scenario. So you're on the highway going 60 miles per hour when all of a sudden you get distracted by a bird. You lose control and then suddenly you're going at around 100 miles per hour, but this is only for a brief second. Because after that, you realize what's going on and fix accordingly. At the end of the trip, you calculate your miles per hour and it comes out to 61, 62-ish. That feels kind of strange since you were going so fast for that one moment. That's what a limit is about. We're not really concerned of what happened around it, just at that exact point. Naturally, this ties into graphs and mathematics. So let's see what that might look like. Here, I've graphed this function. F of x is equal to x squared minus 1 divided by x plus 1. And it looks like a normal line, except when we get to x is equal to -1. You can see here, I'm approaching it from the right side. And when I get there, it says -1, comma, undefined. And then if we do it from the left side, you run into the same problem. Well, can't we clearly see that that's just y is equal to -2? Well, let's see what happens when we plug in -1. If we plug in -1 into this, we're going to get something divided by 0. And as we know, dividing by 0 in mathematics is not allowed. So what's really happening here is a limit. We're getting super duper close to this -2 value without actually touching it. That is the limit at x is equal to -1. Let's write that in math notation. Okay, so in math words, this is how we would do it. We're going to write first lim, short for limit. And here, we're going to write what we're getting super duper close to. So I'm going to write x approaches -1. And we write our function here, which is just f of x. You could write it out if you want to. I'm just going to write f of x. And here, it is equal to -2, since that's what we get from the right side and the left side. And first you might ask, can you clearly see it's -2? Why does the right side and left side part matter? And to answer your question, we're going to see a quick counterexample. Let's see the graph here of the square root of x minus 3. Okay, so from the right side, we get there, and it looks like there's something there. Okay, 3 comma 0, limit at x equals 3 is 0, right? Not exactly. Because for a limit to be defined, it needs to exist both on the left side and the right side. Not just them being equal or the point being there. The point being there actually doesn't matter, like in this case. All right, so let's see what we do know about this. We know that from the right side, it's equal to 0. So how do we write that? We're going to write something similar to the statement on top. All right, so we're going to write limit as x approaches 3 in this case of the function g of x. And that's equal to 0. This is what we would want to write, but we need to make a slight correction because it's on the right side. To account for it being on the right side, we're going to write a little plus sign. And naturally, if we want to write the left side limit, we're going to use a minus sign. So let's write that out. Limit as x approaches be from the left, g of x. And now you run into, what do we write when there's just nothing there? You're going to write does not exist, or DNE for short. This is how we communicate that it does not exist. Correct? 3 little letters here. Not exist. And since the left side and the right side don't match, as condition 3 here clarifies, that means the limit in general does not exist. So we have these two leading to the final verdict, which is that limit as x approaches 3, no plus or no minus. This is just the limit, the general limit, g of x 2 does not exist. Since they don't match, the limit does not exist. All right, let's see some more examples. Okay, here we've got a piecewise function. We've got like some square root curve and then some parabola. Okay, so for this x equals 1 here, let's approach it from both sides. Okay, so following it here, we eventually get to 1, 2. Okay, so the right side limit exists. Let's try the left one. Okay, we get 1, 1.41, which is approximately the square root of 2. So we have a limit on both the right side and the left side. So is there a limit in general? The answer is no, because they don't match. So let's see how we can write this mathematically as well. All right, so for this guy, this is h of x we're dealing with. Let's do the left one first. So 1 from the left side of h of x is going to be equal to the square root of 2, the 1.41 part. Okay, and now for the right side, 1 plus for h of x, that's going to be equal to, let's say, 2. And since these limits don't match, we end up with the conclusion that the general limit does not exist. So if they were to ask you, at x equals 1, does the limit exist? The answer is no. So x approaches 1 h of x, that is equal to, does not exist. Well, it being equal to does not exist is not how you'd say it verbally, but mathematically, this is what you would write. The limit simply does not exist. All right, and now for the last one. The things we approach don't necessarily have to be nice numbers either. So, for example, e to the x. If we want to approach, let's say, infinity, we can do that as well. Because for e to the x, you can see, zooming out, it just keeps getting bigger and bigger. So we can do that as a limit as well. So for this function, which is just e to the x, as x approaches infinity, we could write j of x or just e to the x. I'll do e to the x here. As x approaches infinity, this also approaches infinity, since it just gets bigger and bigger, right? And if we want to do the left side here, as we approach negative infinity, we can see it essentially just flatlines to 0. So another limit we can do from here, limit as x approaches negative infinity of e to the x, we approach 0. All right, so these are the three main conditions you need to know to determine if a limit exists. And with that being said, I hope you enjoyed this video.